It is Monday, August 7th, and we have lots of demos today. How about Paul? Would you like to start?
Sure. So I am going to demo the end-to-end experience for the SI launcher. So if I run the command which SI, we currently don't have an SI binary. I can now curl against the auth portal and an install script. So it's a curl bash script. It will go off and it will fetch the latest, and you can see it is downloading the specific binary for my architecture. Ignore the download URL. That's because of the fact that we can't download easily from a public location, but we need to give it access so we can install it. Now I can say which SI. We have an SI binary, and we actually have a running system. So if I say SI, firstly, if I cancel that, and now I say Docker PS, there are no Docker containers for anything for system init. There are no Docker image ls. There are no Docker images for anything to do with system init. But if I run the command si start, then it's going to download all 9 containers now. So this is the end-to-end system, and this includes actually pushing the pieces of the puzzle through into Veritech itself. Now, there is a step that would happen usually if you've run this for the first time, and it would prompt you and ask you for some credentials. Those credentials would be your AWS credentials and your Docker Hub credentials. And that was to allow you to be able to actually create resources in AWS and to be able to inspect Docker images in the Docker Hub. But this will be finished very, very shortly. I hope. Looks like it's getting close. And in my Docker desktop, you'll actually see them loaded in. So SDF is in, web is in, hotel call is in, console is in, Nats is in, Pinga is in, and I think the last few are just about to arrive. There we go. There's Jaeger. I think we're just waiting on Postgres. Come on, Postgres. It's the largest container. There we go. So we now have containers all running. I can actually go to the containers and I can go and have a look in SDF. And we can see that SDF is currently running all of its migrations. So all of the pieces of the puzzle. If I go back and have a look at what's here, I can say SI status. And SI status will now report that all of the instances are up. But SI status also has the ability that you can grab some Docker logs. So I could say -S for show logs and -L for log lines. And it's actually grabbing the Docker container logs out. So if you don't actually have access to Docker desktop and you would have to use the Docker CLI, then you can actually see all of the pieces that it's doing. So SI launch will open the web UI, which will of course take us to the auth portal, the main auth portal. There we go. The last one has just finished, just perfectly on time. I refresh, I can see it's online. There's a small edge case happening at this moment in time that when we log in for the first time via SI launch, we don't get the assets. So Theo's looking into this with me. If I refresh, we actually do get the assets. I think there's like a timing scenario here, but the most important thing is that I can go and I can actually check out Whiskers, and we should see the qualification passing because we're passing in all of the details end to end. There we go. So we have a working system end to end. SI stop will stop all of the containers, and they're exiting one by one. There we go. And lastly, SI delete will clean up all of the containers that goes with it. So we have a full end-to-end system. I'm hoping that I have one small bug that I'm fixing right now that I noticed when I coded this, but I think this is going to be available for the team to take for a test drive today.
That's come together so well. And I love the logging. Like there's lots of just like little delighters in there. And I think, you know, all of the feedback that you've gotten and the ability to sort of react to that and respond to that. It's awesome. Awesome. Very good. All right. Wendy, would you like to go next?
Sure. So these are changes to the auth portal. So we're going to go ahead and log in. fresh login. So everything here is the same. Let me just continue. Now this form, the GitHub and Discord usernames are optional, but obviously we still ask for them. And then after you save your first set of the form, there is this form that asks you the questions we used to ask on the Corp site. You can optionally skip this form, or you can submit your details. If you submit an empty form, it will automatically treat that as skipping, and you'll go straight into the tutorial. Also, this is not super visible because I'm using my System Initiative email, but the portal no longer has the block if you aren't on the list of users that we've added to the private beta, so that now it will be an open beta.
Sweet. Awesome. Looks great. Very good. Victor, would you like to go next?
Yeah, of course. So this should be pretty fast. I'm going to be demoing like what's the final experience, the release version of the module sharing experience. The idea is that the remote list is not going to be shown up if you're not using a system init email. Right now, the way it works is if I create a module here, let's call it the demo region with a version number 1.0, and then we'll list the assets that we're going to join. I'm going to add to the package, so to the module, sorry. Export it. We'll wait for a little bit. Since, this is not reactive, so we need to reload it, but we're going to get the demo region here. And this is what the module that is not installed looks like. You can click on the view functions, and then you get a list of like all the code, so you can like take a look at what's up and make sure you're not installing like literal malware into your computer. And then if you click to install it, you're going to get it right now. And this is like a very much an implementation detail. We're keying it by hash instead of by name. So now we can actually like, the ID is actually, the identifier is what the code actually is instead of the name. And selecting like either the version, the local or the remote version will give you the same view here for installed stuff, which we discussed if that's what we should happen, but it feels like it makes sense. Then like I don't know, you can have like in the future you can have like an uninstall thing that will bring back to only the remote version. This is not the requirement is still on main currently. If I go into the modules list, we don't have the remote list anymore. And yeah, I think that's it for today. But it's functional, and now you can really upload a model. Like the module repository we're looking at is the global one that we put up like last week. So that's something like there was stuff here that Paul had uploaded, and yeah.
Nice. That's great. All right, Nick, I think you are up.
Okay. So this has been a long time coming, and I've been working with Jacob a lot, and Adam, Britt, Jacob, and I did a lot of research beforehand. But today we're going to be talking about the sequel to the attribute values work we did last spring, and this is a pretty major re-architecture of the system, and we've been tentatively call it mostly everything is a node or an edge. For the purposes of this, I set a little stopwatch for myself because there is so much to cover. So we're not going to get into the super technical nitty-gritty things like what are vector clocks and how do they work. But we're also not going to be going so high level that we continue to generate questions and want to provide some answers on what we've been doing. So this is going to very much directly affect the user experience. How did we get here? And what even is here? I'm going to answer how we got here before I answer what here is, so bear with me. So we were talking about module installation and sharing modules and the life cycle of them. How do they exist in your workspace? How do they change? Do you want to make them edit to one and republish it upstream? Do you want to fork? Do you want to rebase from someone else's? Do you want to do all this stuff that's different kinds of operations and different webs, and it just becomes super complex and challenging to solve? And we wanted to solve content addressability. So the ability for you to sort of access a content addressable store where you don't have to install the whole module. In essence, there are bits and pieces of it that are readily available that you need, like maybe a schema or a function, and you can sort of divide it up so that it's not these huge package files wholesale. And a bonus is workspace portability, because when we went down this work too, not only can we wrap up all your stuff into a module, we can actually wrap up components as well in instances. So Paul's previous desires to have things like templates, this work enables that to happen more easily as well. So let's talk about what the whole new world looks like. Essentially, there are three things: the workspace as it exists today, the change set, not as it exists today, but refactored, and a workspace snapshot. And essentially, workspaces are your tenancy. That's your workspace ID. Change sets are your visibility. Hey, whatever you want to do is that thing in the direct acyclic graph I'm looking for. And then finally, the real core of this work, the workspace snapshot. A workspace snapshot is an immutable directed acyclic graph that when it's stored in the database, it's serialized. In other words, we just wrap it up in a JSON thing and just shove it in the database because it'll never be changed. It is purely copy on write operations. So mostly everything is a node or an edge. This is why it is what it is. Attribute values, components, schemas, schema variants, functions, modules, all of it go on this graph. Their database tables effectively, they go away. Don't need them anymore. Node kinds are basically of two different kinds. There are containers, objects, maps, and arrays. Yes, they have returned. As always, they're the hardest things we do here. And other kinds of nodes that are your more terminating types. These are like strings and booleans and numbers. And edges on this graph, they have weights that contain their own clocks. And I said I wouldn't go too deep in the vector clocks, but what I mean by this is edges sort of have to be a little more intelligent than just this attribute value points to this function, or this container array contains this element, because we have to worry about things like ordering and did upstream remove the item, or did I remove the item, or did we both modify the same item? We got to be able to answer those questions, and that's what vector clocks help us do. Change sets explicitly become pointers to workspaces and are not nodes. Workspaces are root nodes for immutable directed acyclic graphs. And as usual, I could read down this whole list below, but the long story short is that visibility and tenancy, they go away. Well, they somewhat go away. Tenancy goes to the workspace, and certain tenancies can only see certain change sets, and certain change sets are only visible to certain graphs. And all those writes you make, every time you even update a character in a name, we create a new graph. We do not modify the old graph. Everything is content addressable. The nodes on that graph have content hashes that point to our store. And the last thing I'll say before I talk about that store is there's this idea of a base change set name. This would be your equivalent to main. So when you create a new workspace, we'll probably by default give you main as the base change set. So then when you make a new change set with a new workspace snapshot and you want to rebase onto main, or from a user's perspective, merge your change set into main, then we're just going to update the change set pointer. And now you're back on main. All right. How is everything stored? So we talked about how we needed a content addressable store, not just like to get to a module, but like the things inside the module, right? Well, in memory in Rust, and this is actually pretty powerful, this isn't directly related to the storage, but when working with the graph, there's no back and forth to the database. That all happens in memory in Rust. We're using pet graph under the hood, and we've been able to get update operations for the equivalent to whiskers, or maybe a little smaller, in under a millisecond. So it's lightning fast, much faster than before. In fact, it was so fast that since we can't share ULID generators, we had to find a new way to stamp timestamps because it was so fast that it outpaced how quickly we could generate ULIDs without reusing the same generator. And this is related to storage because we're pulling everything into memory in Rust. So content addressable store, key value store in the database. Currently, we're using Postgres just with 2 columns. Same thing with the workspace snapshots, by the way. 2 columns, workspace snapshot ID, graph. You can see where we're going here. And the nodes on this graph, they have 2 things. A content hash. This is analogous to your attribute value. So this would be like If you're an object, this would just be the braces. Or if you're a string, this would be foo, if it had value foo, and the Merkle tree hash. If you're an object with 2 fields, this would be the object and the 2 fields and their values. And that's equivalent to the attribute view today. And those things are available in that content about addressable store, as well as locally in memory. Again, everything's coming out of SQL. We're working in memory and Rust. We're getting really fast operations. So looking at the clock, I'll move a little quicker. This means Postgres is likely going to be replaced. We just do not have relational things to use anymore. And I can answer questions on that after the demo as well. Why not a graph database since we're working with graphs? Because we're really not working with graphs. We're working with serialized graphs that we just shove into the database. We're not updating nodes and removing edges and reparenting. We're just stuffing it in, copying it all, and moving on. And what that means is we actually get something more in the shape of a key value store, where things like AWS DynamoDB, NoSQL, key value stores, and other things work well. For the first turn of the crank, we don't need to replace it, but we might find performance-wise that we will do it earlier than we think. And rest assured, we're making sure things still work in flight when this happens. So the last thing I'll end on is you might be asking, all right, who's doing all this, right? Well, the Gobbler does. And the Gobbler is a new service that performs these graph operations, these copy on write workspace snapshot operations, and when you create the new workspace snapshot, how to take the change that I'm looking at and point it to the new thing. And it has this conflict detection. Now that's what Jacob's been really hard at work, and him and I paired on to deliver to the end. It's done now. Fingers crossed. We're just adding some additional tests. Things are moving pretty well. And this is essentially similar to like when you're comparing 2 branches in Git. Although from the perspective of the user, we can turn these into human readable messages like, hey, we noticed that upstream looks like this, yours looks like this. What do you want to do here? Do you want to make this your own? Do you want a fork? We're going to give the user as many options as possible, but we're talking about the low level right now. And then as another architectural decide, it needs a durable queue, which Nats cannot provide in the event of an outage or other things. So RabbitMQ will be how it consumes. Again, in the interest of time, I'm going to skip over why RabbitMQ more in depth, but it's durable, whereas Nats for this use case is not for this kind of queuing. So it takes 3 inputs, the Gobbler. It takes the change set ID of what you want to do, right? It takes the work of what you want to merge into, or rebase onto, rather. It takes the workspace snapshot ID, which is like your new graph, like all your writes, like your change names and whatever, that should be rebased on top of the snapshot that the change that currently points to. And the vector clock, which is like, hey, what has been like done to this snapshot? And the third one's a little complex, so we can gloss over that at the moment. It's mainly the first 2 that are important. So there's really 3 scenarios, and now we're talking all the way back up the front end where this will happen. You'll rebase on the name, main. This is like if you have a change set and main changed a bunch and you went on vacation, you came back and you were working on something and you're like, man, I need everything that happened on main. Like I need all that stuff that happened. You're going to rebase your stuff on the main. So the name change set is the one you're trying to rebase. The workspace snapshot ID is mains and the vector cloud ID is mains. So you are rebasing on top of main. Well, merging onto main may sound different. It's actually just the opposite. So to the Gobbler, I'm going to provide the main change set ID. Then the workspace snapshot ID and the vector clock ID are going to correspond to the things I've done. And then finally, there's like the question of I have a change set and I just keep writing to it. I'm not into the merging or the rebasing yet. Well, we're actually going to create little change sets. You're going to have this named one, maybe called Nick Dev, right? Or something like that. But that's how it's going to present in the front end. Every write you make is actually going to be a new change set under the hood. And we're just going to constantly rebase them into one another. Since we're at like almost 12 minutes here, I'm going to stop there. I really want to show you code. I really want to show you more. We were perhaps a little late in showing you all this and some code as well. But essentially, the long story short is if there's anything to take away from this, it's that the graphs are all immutable. Everything's copy on write. Everything's content addressable. We can detect conflicts. And with this system, we're actually going to get way faster read and write operations than before, less SQL, so easier maintainability in Rust, probably easier operations with the front end as well. We're really, really excited to deliver this to everyone. And that concludes my demo.
Sweet. Any questions from anybody? Cool. Thanks for walking us through that, Nick. I think, like, you know, the journey of how we got here is fascinating, because when you think about the types of work this will unlock going forward, like it can be easy to like separate how we got here from the work that you're doing, especially when the objective is keep the system working as it does functionally. But yeah, you can, that path is important to remember, an important context, because if you think about the implementation of these algorithms that you're writing, or like these low level nitty gritty, you can always point back to, well, what is this doing for the users and what is this doing for the product? And yeah, good stuff.
Yeah, the way you can think about that, that's precisely right. The way it can get easy to get caught in the technical details, but the way you can think of like the Gobbler and the graphs, they purely exist to say, what if a user wants to do X? And this new system enables us to say yes to all those questions in the way that the old one does not.
Yeah.
And that's like the great synthesis you could take away from this is, can I do X with a module? Can I pull this function? Can I fork? Can I rebase? Can I merge? Though in the current state, you cannot do all those things. And in this one, you will be able to.
Yeah. Yeah. Cool. Very good. All right. That concludes our demos. Thank you all for sharing.